Hi, everyone, and welcome to the session, Database Observability, Your Weakest Link. My name is Kevin Kline, and I'm a head geek with SolarWinds. I've got over 30 years of experience in a wide variety of roles as a developer, as a data scientist, DBA, enterprise architect, and a manager of IT teams. Over the years, I've written a lot of books, I've written a lot of blog posts, and I'm very active on social media. If you're interested in databases, enterprise architecture, that sort of thing, I hope you'll follow me on social media, maybe look up my blog and give it a read. I'm also a Microsoft certified MVP since the 2003 year. I was awarded at the end of 2003 into 2004, and I write a monthly column as well for Database Trends and Applications magazine. My most popular book out of many is SQL in a Nutshell. So what are we talking about today? Well, we're actually going to talk about observability. Now, observability is a bit of a catchword, if you will. And many people tend to think of it as meaning the same sort of thing as the word monitoring. However, monitoring is actually a verb. Let's monitor this system. Whereas observability is more of a characteristic in the same way that a system might be described in terms of high availability, stability, or reliability, those sorts of measurements, right? So observability is a measure of how well the internal states and conditions of a system can be inferred from knowledge of its external outputs. That's the definition. And, so monitoring is kind of this older fashioned, let's say something like a sextant, whereas now we have GPS, right? That's what observability is. It's more sophisticated. And so to compare the two, with monitoring, we are basically in a scenario in which we kind of know what to expect. We know what the problems are likely to be. So in a database context, I know that I need to keep an eye on CPU, on memory utilization for both the data cache and the planned cache in SQL Server. I need to keep an eye on other kinds of caches like the log buffers and things like that. I need to keep an eye on I/O, vastly important. And so we know what we need to watch, and we pre-configure different kinds of alerts according to the kind of performance issues we expect to see in the future. When we build out monitoring systems, we build out dashboards that are really built around certain sorts of assumptions that we just expect to happen. However, that's because of the way things have been historically. I'll talk about that a bit more in a moment. Compare that, though, to observability. And observability is designed to satisfy our needs to know what is happening with our IT systems in a very different sort of environment, in that it's now much more complex. We're building multi-level, multi-component IT systems. As before, with our older way of doing things, the database is still really the heart of the value in this particular sort of scenario. The algorithms have to process against that data. The user interfaces have to interact with it. But to make that system highly observable, we have to take in as much performance information and other kinds of metrics across all kinds of different endpoints, you might say, because now we have to deal with microservices and mesh, and we have to deal with IoT, or we have to deal with containers orchestrated through Kubernetes. And so it's not just a client server app or a web app connecting to a Azure SQL database or a SQL Server database. Now we have an enormous explosion in the number of things that we need to monitor, and we don't know what's going to come out of it. So how can you build a dashboard if you really don't know what to expect at all? So that's more or less the difference. And it comes as a historical artifact, right? As so much of what we do in IT is accretive. It builds up layer upon layer over time. So you go back to the start of my career in the mid-'80s at the tail end of mainframes and mini computers and that sort of thing. And if you were a user on the system, it was you. There was some kind of magic in between you and the database. And that's all there was, right? So if I was working against the HPUX system or Data General or my beloved VAX VMS systems, there just wasn't that much you had to debug, and you didn't have lots of moving pieces to keep an eye on. Then throughout the 90s and even into the 2000s, we had more complex sorts of arrangements. We had the database across multiple layers of networking, across multiple firewalls, different routers. Maybe there was some sort of wide area network at play, and we may have had, different kinds of applications connecting to those. But what we've seen in the last several years is something much more like this, where there's an infinite number of moving parts, or at least an immeasurable number of moving parts throughout. So in a situation like this, we might still have on-premises components to our application, but then a big portion of our application may be on one segment of our hybrid cloud. And then we have another cloud vendor who is also providing a number of services to us, and lots of little tiny components like microservices connecting instead of one big kind of monolithic, thick client front end. And so that's the challenge, right? This is much more difficult to monitor and keep an eye on compared to what we are used to in the old days. And that begets the question of what is important to monitor. And with our older way of doing things, we had a kind of a short list of what we would typically use to monitor a SQL Server, or even other database platforms out there, maybe PostgreSQL or MySQL or something like that. And so you would use things like perfmon counters and stuff like that. Now, early in my career, I actually did work on the Hubble Space Telescope down at Marshall Space Flight Center. And it was a really neat and interesting challenge, but it was also very straightforward. And so to answer this problem with our most straightforward approach would be to use what is now famously called Google's 4 golden signals, okay? And there's a reference to the site reliability engineering book that Google has published about this. And the 4 golden signals kind of represent latency, how much time is spent waiting in the queue to get your work done, traffic, which is how busy is the service upon which we're placing our different kinds of demands, errors, the number of those transactions that fail, and then finally saturation, which is basically a measurement of how full or how busy is this particular resource. From 0 to 100, how much is it being utilized? And so we need to keep track of these things. That's the way that the site reliability engineering approach works today. However, there are also lots of other kinds of approaches. There's something called the use protocol, which emphasizes utilization, saturation, and error rate by a person named Brendan Gregg. We've got RED methodology, which is rate, errors, and duration by Tom Wilkie. And we have a lot of other ones. There's something called CASE, context-heavy, actionable, symptom-based, evaluated. So there's a lot of different ways you can kind of roll up massive amounts of information that are collected to provide observability, and this enables us to really not know what we need to keep an eye on, just to be able to observe things in such a way that when something does happen, we can get to the root cause of that problem quickly, okay? So having said that, most of the inputs into these systems, like applications and your microservices, containers, your orchestration system, we have to instrument those too. So in this new era of observability, compared to monitoring, in observability, we probably need to do something different with the front end code, with the different kinds of algorithms we process against that data set. So for a long time as a DBA, the dev teams would write code, but there was nothing really written in that code to send out debug signals. There wasn't a lot of stuff to build out logging of different kinds of steps along a process. That has changed. We need to do that now in order to make sure our systems are fully observable. because we can't anticipate what the problem actually will be because there's so many moving pieces now, whereas before we had just 2 or 3. So I previously showed a picture of the Hubble Space Telescope. Just to carry that analogy forward, what we're doing with observability is we're getting bigger and better. And in this case, this is the Webb Space Telescope that's just about to launch. As you can see in the image here, it is enormously bigger than the Hubble Space Telescope. And there's 2 things that make telescopes more powerful than others. The first is the size of the lens, the mirror designed to collect all this light from the universe. And the second is the curvature of the mirror. And so the Webb Space Telescope has almost overlapping onto itself sort of curvature, whereas the Hubble Space Telescope has a dish shape, if you will. And what does that mean for us in terms of what do we collect? Well, there's a short answer and a long answer. The short answer is we collect as much of everything as we can. Again, we're not sure, but what we do know is that the more data we have about, the more metrics, the more telemetry we have about what is happening in your application, from the database through maybe the virtualization or containerization layer to the virtualization host or the orchestration to the bare metal. If we can put all of that together, then we can enable our systems to be fully observable and very, very diagnosable for any sort of problem or anomalies that happen. And so across the different product lines that we have at SolarWinds, we look at things like perfmon counters, certain kinds of values from the SQL Server dynamic management views and dynamic management functions. We look at Windows management instrumentation and other kinds of operating system level information that you might even find in other operating systems like Linux. We also have a few, in the old days, we used to have a lot of specialty DBCC commands like mem usage. Now we only have a couple that provide information that can't be found through other methods. We collect that. And then finally, all kinds of logging. So we want to know about security logging and application logging and event logging and SQL agent logging if we're running on-premises SQL Server, and different kinds of logging according to the different services we're using in the Azure cloud. So why throw that away when we're not sure how important it will be in a given circumstance? One of the things, though, that we do with our product line, at least, and by the way, if you're wondering, well, how did we do this before? If you were to look at my collection of videos, webcasts, and blog posts, it would take hours for us to go through all of these different perfmon metrics and the value they have and which ones are valuable and which ones are less valuable. Same thing with dynamic management views. You know, you don't use everything every time, all the time. You only use certain things at certain times. And so we build our products with a certain sort of philosophy, right? So if we want to abstract out our hardware, for example, then we're going to look at things like the virtualization, containerization. Helps us save money, right? If we need to know more about, say, the software abstraction layers of clustering and availability groups, then we're going to do that in order to have a better service level, to have less downtime, to reduce our risk, right, and ensure high availability. You could do those things before the era of observability, but it was just much, much harder to do. And you could find lots of caveats, provisos, and other sorts of kind of asterisks at the end of that sentence because it might be too hard to do, depending on your application and how much workload it put onto the database. So when you're trying to solve problems, you're going to use the observability approach. A couple things to keep in mind. High-level dashboards are very, very helpful. They help you roll up everything that's happening into kind of a thumbs up, thumbs down sort of situation. And that can really help you get to a root cause analysis, get to the smoking gun if there is a problem. However, sometimes there's not a specific problem per se, there's just a general performance issue. And so with different kinds of query and table tuning capabilities, you can find out where you have not breakdowns, but you have inefficiencies. And so Yeah, you can do that with the existing toolkit inside of Microsoft SQL Server, inside of Azure SQL. But again, you have to know what you want to accomplish. And if you weren't watching beforehand, you will never catch it as it occurs. And then finally, it takes a lot of time and energy to put these kind of solutions together. And so the good news here for you is that we have a product line that is designed to do exactly that. Our product called Database Performance Monitor is designed to solve challenge 1. Our product called DPA, Database Performance Advisor, is specifically very powerful for challenge 2. We have a combined SKU for DPA and SQL Sentry that can solve 2 and 3 very quickly and easily. And then finally, challenge 4. That's all about SQL Sentry. And so these different products are designed to cover all the bases. If you want to run things like a site reliability engineer would, you would probably stick with DPM here in the center. Whereas if you wanted to focus on your query and table tuning, you could lean heavily towards Database Performance Analyzer. And then finally, if you needed that full stack observability, everything that there is to know, that would be SQL Sentry. And it provides a variety of interesting value adds. For example, correlation across all the different performance points in your application. It gives you things like anomalies and identifies those. In the same way, Database Performance Analyzer gives you a lot of kind of that broad information, integrates into the Orion platform, app stack, perf stack kind of integrations. It has some really neat machine learning to help point out anomalies when they happen. After all, if you don't know what normal is, how can you actually be sure that you are being identified for abnormal situations? You have to have normal first before you can have abnormal. So each of these has a sweet spot. Each of these can help you run your SQL Server Enterprise, whether it's on premises or in the cloud, whether it's single provider or multi-provider, and you have a hybrid solution of all of those things at once, that this is the solution that's for you, the premier database observability and monitoring platform. So with that, I want to take a moment and kind of encourage you to take a look at the different sorts of resources that we have available for you. We have, of course, all of my blogs and so forth. I have a lot of videos. If you're interested in learning all those particular things that I covered very, very briefly, things like what are the perfmon counters that I should keep an eye on? What are the DMVs that I should pay a lot of attention to? And you don't have a tool and you don't feel like you can get a tool, then absolutely learn that at my blog, learn that at my video website. Follow me on social media. I'm always doing new things, as well as others at SolarWinds. And then take a moment and look at our different products. I'd love to give you a trial of any of these. I'd love to give you a demo as well. And also for DPA and DPM, we have online live interactive demos that you can actually just sign right in and interact with those right away. So you don't even have to download anything if you want to give that a try and see how it works. So with that, I want to thank you for the last 15 minutes of your time. I know you have a lot to do and you have a lot of constraints on your time, so I'm very appreciative that you spent it with me for these last few minutes. And with that, I'd like to encourage you to take a look at these different tools, see how we can help you, and of course, see how I can help you if there's anything else I can do in that regard. And with that, I want to thank you for spending your time with me. I hope you have a great Microsoft Ignite, always one of my favorite conferences of the year. And let's talk soon. Bye-bye.